I'll see my screen.
Yes, we can see the screen.
Yeah, so it's an honor to be here, and I'd like to tell you about some work that I did joint with my colleague Mika Gabel, who's also at Afeka College. So like a lot of you, we teach a large coordinated calculus course in our college. There's about 800 students in calculus, and most of the lectures and most of the lecture groups use Chalk Talk, and then there's also some recitations, and then there's some homework. So there's a lot of constraints about what kind of changes you can make to the course because there's a very rigid schedule that all the lecture groups have to follow. And of course, the content is very strict because all the groups have a coordinated final exam. So what we wanted to do is we wanted to improve what happened in our groups with a small and scalable modification that everyone can do in any of their lecture courses. So before we continue, I think maybe many of you have probably taught something that's similar to what I'm describing here. So I would like you to take a minute and answer this survey. So you can use this QR code, get out your phone, scan it, and answer this survey about what would be important to you in a calculus course.
Yeah, there's no QR code.
It's not showing?
No.
Yeah, we don't see.
Is it that perhaps
Oh,
Yeah, that's
okay.
better.
yes,
Now-
no, not showing.
Yeah, it only showed one window, I guess, sorry. Great, so I see people are starting to answer. So now I've given you an opportunity to think about this on your own. And in about 30 seconds, Zara is going to put you all in breakout rooms. And you're going to have the opportunity to discuss with whoever's in your breakout room for about 2 minutes why you chose what you did and why that was important.
Question things. And I think calculus is a really good platform for doing that because you have a lot of proofs and you have a lot of, you have to understand why what you're doing is working and how it's working.
That's wonderful. That's exactly how we think about it. And would someone like to share why they thought student participation was important?
Thank you so much. I think when we increase student participation and engagement, we make the learners own the process of learning and they appreciate what they're doing. So it will be, they make them part of the class, and as a teacher, you benefit from this as well. Thank you.
Thank you. That's beautiful. That's exactly what we wanted to get to also. So our goals were that we wanted to increase student engagement and participation, especially because we teach a lot of weaker students, and we think that if students are more engaged, then they'll learn better. And we wanted to improve how students prepare at home. And our method of doing this was with active learning, which in a lot of literature has been shown to improve student achievements. And it reduces the achievement gap for underrepresented students. And I teach in Israel, so for us, underrepresented students are Israeli Arabs, Ethiopian, and ultra-Orthodox students. And the other thing that doing this kind of thing can do is that it can increase student self-efficacy. And self-efficacy is the strongest predictor of student achievement, and it can be increased by providing mastery experiences. So doing like what we did now, where you get a question and you solve it on your own, and having that experience repeatedly in class can increase student self-efficacy and student participation, and hopefully help them do better in the course. So what did we do in our classes? So Mika and I were the two lecturers, And between us, we had 5 lecture groups, which is about 250 students out of the 800 students in the coordinated calculus course. In our college, everyone takes the same calculus. So there's 7 different engineering majors, but they're all supposed to have the same entry requirements, and everyone gets the same level of calculus. And in all of the 5 groups which Mika and I taught, we had 4 in-class peer instruction quizzes. So that's exactly what we did now, where you guys did a question on your own. And then I wanted to put you in groups to discuss and have you answer the question again. So we did this process 4 times throughout the semester. And then we had a final review that was exactly this process, where the whole 2-hour class period was spent doing a question on their own and then the same question in groups. And every time we did one of these, we surveyed the students about if they felt they could answer the problem on their own or if they felt the activity helped them. And then in 3 of the 5 groups, so we left 2 groups as control groups, every week we added self-work sessions. So that would be, we just did the first part of what I wanted to do with you, where we asked them to solve a question on their own during class time. So here's the breakdown of what we had. There were 5 different groups that had different kinds of engineering, and the numbers in each group depend on if you look at the enrollment at the beginning or the end of the semester. And then you can see that there's 3 groups with self-work and 2 groups with peer instruction only, and then the totals. And then also to help us throughout the semester, we had periodic meetings with the pedagogical advisor. And in order to keep track of what was happening, Mika and I both wrote reflections every week, and then we reviewed the reflections at the end to see our impressions throughout the semester. So what kinds of self-work questions can we ask? So this was in the 3 groups every week. So there were 3 main types of questions we could ask. So one question was like a scaffolding question. So for example, when we needed to prove that the limit of the nth root of n is 1, we had to use the binomial formula at some point during the proof. So instead of starting the proof with the binomial formula, we had like a pre-work that was to expand 1 plus x to the 3rd using the binomial formula. And then when we actually did the proof in class, the students got less lost in the binomial formula part. Another way that you could use this is you could use it to give review or feedback. For example, here's a question about the intermediate value theorem. Does this odd degree polynomial have a real root? Or you could check conceptual understanding. So for example, you could ask your students to give an example of the limit of a function where you change x approaching a to be infinite or finite and the limit of the function L to be infinite or finite. So how did we collect data? So we had the online quizzes and surveys, which is the process that you guys did, which we did 4 times during the semester. And then we surveyed students every time. We looked at their exam, how they did on the exam. And then we looked at our reflections. And then we also in-depth analyzed their writing on 2 exam questions, which I probably won't have time to tell you about. So what we wanted to know is we wanted to know, how does this process of adding self-work and peer learning affect their engagement in class, their communication, written and oral, their self-efficacy, and their overall achievement in the course. So before we continue, I want to show you a video of what happens in our classrooms. I don't know about you guys, but when I ask students to do a problem and I write the problem on the board, they usually just sit there and stare at me and they don't want to do the problem. But when I use MathMatize, they do it because it's in their phone. Like you guys all had to answer the question because it was in your phone. So I want to show you. This is our classroom. So this is. And you can see that they're excited because it's in MathMatize, so they have to, it's in their phone and they all have to answer the question. So thank you to the creators of MathMatize for bringing me this wonderful tool that really helps me get my students engaged. So what did we find from our data? So we did the peer learning quizzes and we did 4 capstone problems throughout the semester. So there was a capstone on sequences, on continuity, derivatives, and integrals. And then we chose 2 questions from the final to look at. And we looked at the difference in the groups that solved problems on their own every week and the groups that didn't. And you can see that the trend is that throughout the semester, the groups that did solve problems on their own every week are doing a bit better. And then every time we did one of these capstone problems, we asked students if they felt that they were capable of doing the problem on their own, and if they felt that the peer discussion helped them. And you can see again that the students that solve problems on their own are doing slightly better. And they also find that the overall activity helps them more. And then finally, we looked at student achievement in the final exam. Okay, so you can see that there's 4 groups here. So I have the groups that solved a problem on their own every week. The 2 groups that were control groups, they didn't solve problems on their own, but they had the 4 capstone problems where we did the peer learning activity. Then the 3rd column is the course average. And the 4th column is the average of the other groups, the groups that were not Mika and I's groups. So you can see that on average, the groups that were taught by Mika and I are doing a bit better than the course and a bit better than the other groups. But what I'm really proud of is I'm really proud of the second line, which is the failure rate. Groups that solve problems on their own every week had a lower failure rate than the course total and lower than the other groups. So I think it's really important to get the students to be involved. And then you could ask, okay, so where exactly is this difference coming from? So now you'll see 4 lines. So the blue is the groups that had self-work, the groups that solved a problem on their own every week. And the red is the ones that didn't. The yellow is the course total, and the green is the other groups, the groups that were not Mika and I's groups. So it looks very similar, but what you'll see that around 70 to 80, the blue has this bump. So there were students who maybe would have earned a failing grade, but instead they earned a low passing grade, which is where this lower failure rate is hitting us. And then you can also see that the red has a bump, but the red had the bump around 65. So the groups that only had the capstone problems and didn't have the problem every week are also earning a low passing grade rather than failing. So I think of course, the students who are on either ends of the spectrum, whatever we do is not going to change their experience so much, but it's really these students that are in the middle that we can try to help the most. And then Mika and I, as I said, we also wrote a reflection every week. And then what we did was we analyzed the reflections independently after the semester ended. And then we tried to extract common themes. So we tried to make it as non-biased as possible. So one thing that we noticed for both of us is that it took time to build the classroom culture. It took time to get the students to work. So initially, when we asked students to solve a problem on their own, they didn't want to, and they just sat there and stared at us. And it took us several iterations of doing this to get them to actually try on their own. The other thing that we noticed is when we asked them to do a problem on their own, I wanted it to take 5 minutes, but of course it didn't take 5 minutes. It took 10 minutes or even 15 minutes sometimes. So this was something we also struggled with, that it took a lot longer than we really wanted it to. But after we kept going with this and we really tried to get our students to do it for a few weeks, we found that whenever we did a self-work question, whenever we had them solve a problem on their own, the discussions afterwards were much more focused, and the students asked us deeper questions. So they asked better questions during the lecture, or they would come to us during the break or after the lecture, and they would even show us their work, or they would ask us why their answer was wrong. And before, when we didn't try to have them do problems on their own, they didn't do this. They didn't talk to us. So that was a nice effect. And the other thing is that both Mika and I both got better at picking questions for the self-work and deciding when in the lesson to use them. So initially, like we had, our plan for how we were going to have this review question or whatever we wanted to do. But then as the semester went on, I got better at deciding, okay, this is this hard thing that's going to be hard for them in this proof. So I'm going to do a scaffolding question at the beginning that's going to set them up for the proof. Or I know that this concept was hard for them in the previous lecture. So at the beginning, I'm going to start with reviewing exactly this thing. So both of us got better at choosing the questions that we wanted to use. And in the end, we found that it saved time because it focused the class better. The other great thing about it was that it gave a lot of feedback both for us as lecturers about what our students were understanding. And it also gave the students feedback about what they did and did not understand. And I remember at one point at the end of the semester, around week 10 or 11, one of my students came to me and said, "Wow, I can't believe I solved the problem. It's so cool. I can't believe it." And I said, "Of course, when you try, you succeed." And then he said, "Yeah, I guess I'm just not used to trying." So it takes a lot of effort to make them try, but when they try, they can do it. And then hopefully they can do it later on too. And we also found that it created a culture shift in the class, that students were more willing to solve problems on their own. They were more willing to try, even when it wasn't one of the self-work designated times. They would say, "Oh, should we try on our own?" And they would try on their own more, like if they came to ask us for help, we would say, "Can you think about this?" And instead of being like, "Ooh," they would actually try. So we found that it changed the classroom culture overall, which was another nice effect. So in conclusion, using self-work and peer learning in class through the MathMatize app, which I love, contributed to student success. It shifted the classroom culture, and it was well worth the time that we spent. So I highly recommend it, and it's a small and scalable pedagogical change that everyone can do in their course. So no matter how you're teaching, if it's a coordinated lecture, you're stuck with a strict syllabus, you can do this. Even if your desks don't move and you can't put them in groups correctly, you can do this. Even if you're teaching on Zoom, you can do this. So it's a small change that anyone can do, and we think it's well worth the time spent. Thank you very much.
Thank you very much for your talk. So are there any questions, comments? I actually see one question from Anna in the chat. So what is the definition of self-efficacy? This is a question from Anna.
Great, thank you. I should have said it better. So it's the students' belief in their own ability. So it's not the measure of their ability. It's not how good they actually are, but it's how good they believe they are. Which especially, for example, for women, you can see there's a lot of research that shows that there isn't really a difference in ability for women and men, but there is a difference in perceived ability, like how women perceive their own ability and how men perceive their own ability. So if we can raise women's self-confidence or any minority group's self-confidence, then they can do better overall.
Okay, thank you. So Luai, please unmute yourself.
Okay, thank you so much. It's an interesting talk. I have a question on slide 10. So I'm coming from statistics, background. So you said that the two